Hello, AP Stat students, and welcome to the College Board virtual instruction for AP Statistics. My name is Luke Wilcox. I am an AP Stats teacher at East Kentwood High School in Kentwood, Michigan. We are right in the middle of AP Prep Week. I hope that you were able to join me yesterday where I showed you a full-length practice exam, 2 questions, 25 minutes and 15 minutes. And we took those questions within that time constraint so that we could feel what it would be like on the actual AP exam. And today is the day where we're going to go through the solutions, and I'll talk a little bit about what I think would be needed in order to get full credit if these were actual AP exam questions. So let's go ahead and get right to it. So a quick check to make sure that you are in the right location here, AP Statistics. Hopefully at this point you know who I am. Luke Wilcox from East Kentwood High School. A few quick reminders before we jump into questions here. This is our final week of AP exam review. We are right in the middle of AP Prep Week. Also, just so that you know, we are giving a second practice exam, full length. Tomorrow, Mr. Murphy will be presenting that. And then on Thursday, he will go over the solutions from that practice exam. And then on Friday this week, we're planning on giving you some AP exam tips and some best wishes as we send you off into your AP exams next week and the following week. Of course, AP Stats is the very last exam. May 22nd is our testing date. Now, any resources that you would like to download for the YouTube Live videos, you can find at statsmedic.com/YouTube, including the practice exam that we took yesterday, or you can follow this link right here, which will also take you to the practice questions that we used yesterday that we're going to go over today. All right, so we are just going to get right to it here. This is question number 1, which was 25 minutes you were given. It had parts A, B, C, D, E, and F right here for question number 1. So what I'm going to do here is I'm going to first write out the model solution for each part. And then once we have the model solution written, we'll look back at that solution and I'll try to highlight the parts of the solution that I think are necessary in order to get full credit. So here we go. The question says, an online company is hoping to sell a new product by placing a pop-up advertisement on their website. There are 2 different designs for the advertisement, and the company would like to determine which one is more effective as measured by clicks and purchases. For the first 200 visitors to the updated website, half were randomly assigned to receive advertisement 1 and half to receive advertisement 2. The two-way table summarizes the results. So we can see over here on the left, we've got the 2 different treatments, advertisement 1 and advertisement 2. And as mentioned, half in each, 100 in each for a total of 200. And then we can see the customer behavior based on each one of those advertisements. Either they did not click, they clicked with no purchase, or they clicked and made a purchase. So here's what question A says. It says, is this an observational study or an experiment? So first we have to know the difference. For an observational study, we usually take some sort of sample, a random sample, and maybe we give them a survey and we're looking for some sort of results, or we're just observing something. With an experiment, the difference is that we are imposing treatments on the subjects. Well, in this particular context, the online company is randomly assigning the people to either advertisement 1 or advertisement 2, which we could think of as the treatment. So the definite answer here is that this is an experiment rather than an observational study. And then we need to provide a good reason for why it's an experiment. So we're going to say this is true because the customers were randomly assigned to a treatment. And then we're going to be specific about what those treatments are here in the context of the problem. A treatment of advertisement 1 for one of the groups, or advertisement 2 for the other group. Now, in terms of what would be needed for full credit here, I'm going to try and highlight this by underlining the important parts. Well, first of all, you have to read the question and answer the question. And the question asked, is this an observational study or an experiment? Here is where we have answered the question. But then we have to explain our answer. So why is it an experiment rather than an observational study? I like the idea that we have random assignment of treatments, but we've even gone a little bit further than that, and we've explained in the context of the problem, what are the treatments that are being given here. So that takes care of part A. Let's move on to part B. Part B says, provide one piece of evidence for why advertisement 1 is more effective. Okay, so we're going to come back up here and let's look at advertisement 1 and look at the numbers. Well, how are we measuring the effectiveness of the advertisements? Two different ways, in the clicks and in the purchases made. Well, if I look here, I see that there were 22 purchases made out of 100, as opposed to advertisement 2, which only had 16 purchases out of the 100. So clearly, if we're basing it on number of purchases, it looks like advertisement 1 is the better advertisement. So we're going to say advertisement 1 had a higher proportion of customers who made a purchase. And then I'm going to make sure here that I justify with some numbers here. So the proportion of customers who made a purchase for advertisement 1, well, that's 22 out of 100. And if we were to write that as a proportion, it would be 0.22. And the proportion of customers who made a purchase is higher than the proportion for advertisement 2. So higher proportion of customers who made a purchase than advertisement 2. And then let's also give numerical justification for advertisement 2 here, which we know is, let's see, 16 out of 100, which if we write that as a proportion is 0.16. So what would be needed for full credit here? Well, obviously we have to give a reason why advertisement 1 is better. And I think specifically, I like this comparative word of higher, the proportion of that made a purchase is higher. And I actually really like here that we've justified it with some sort of numerical explanation that includes a probability there. Okay, let's take a look at the next part, which says, provide one piece of evidence for why advertisement 2 is more effective. So now we need to try and think about why advertisement 2 is more effective. Well, we want customers to make a purchase, but we also want customers to click, right? Whether or not they make a purchase. And if you look here, if I take the total number of customers that clicked for advertisement 2, 20 and 16, I get 36 out of 100. Whereas advertisement 1, 8 and 22 is only going to give me 30 out of 100. So if we're basing the effectiveness of the ad on the number of clicks, it appears advertisement 2 is a better ad. So let's put that into words. We're going to say advertisement 2 had a higher proportion of customers who clicked. And then let's provide numerical justification for this. The number who clicked, remember we said was the 20 plus the 16. So 20 plus 16 out of the 100 total. That's 36 out of 100, which is 0.36. And we're saying that is a higher proportion of customers who clicked than advertisement 1. And let's provide numerical explanation here for advertisement 1. We've got the 8 and the 22 out of 100. And that's 30 out of 100, which would be 0.30. And clearly 0.36 is higher than 0.30. So what's required for full credit here? Well, definitely, once again, I like this comparative word here that we're saying the proportion is higher. And then we've also provided some numerical justification for that one. Okay, let's move on to part C. One customer from the study will be selected at random. Are the events advertisement 1 and made purchase independent? Justify your answers based on probabilities calculated from the table above. Okay, so if these two events are independent, then knowing the outcome of one should not change the probability of the other. So let's start with the probability of making a purchase. And if we just start by looking overall for all 200 customers, let's see what the probability that they make a purchase is. Well, out of the 200 total, we can see here that 38 out of the 200 made a purchase. So overall, 38 out of 200 made a purchase, and that is 0.19. Now, here's what we want to do to determine independence. Let's see if the probability that they purchase changes based on which advertisement they were given. So we're going to do a conditional probability here of purchasing given that they saw advertisement 1. Well, if we are given that they saw advertisement 1, we are only looking at that row, which has a total of 100. And out of the 100, we know that 22 of them made a purchase. So this is 22 out of 100, which is 0.22. Notice that is not the same as the overall probability that they make a purchase. Now, to strengthen our argument here, let's see what happens when we calculate the conditional probability of a purchase given that they saw the other ad 2. Well, now we're only going to be looking at the column for advertisement 2, which we know is out of 100, and out of those 100, 16 purchased. That is 16 out of 100, which is 0.16. So very clearly here, if I know what ad they're shown, that is changing the probability that they made a purchase, which is telling us that these two events are not independent. So let's go ahead and answer the question here. First, we want to say, no, they are not. The two events are not independent. Now we need to be very clear on our justification for why we're saying the two events are not independent. So we're going to say it's because these three probabilities that we've calculated here do not equal one another. All three of them are different. In fact, if any two of them were different, we would know that these two probabilities are not independent. So I'm even going to go one step further here, and I'm going to explain sort of the meaning of independence. And I'm going to say, knowing which treatment the customer received changes the probability that they purchased. So clearly, these are not independent. Now, what would be required for full credit here? Well, we actually went ahead and calculated three probabilities here. Actually, if you calculated any two of those probabilities and showed that they were not equal to each other, that would be sufficient. We sort of went a little bit extra here. Now, once again, you want to make sure that you answer the question that's being asked, which is whether or not the two events are independent. Okay, let's move on to page 2 for this question here. We've got a little bit of setup for this one. So here's what it says. The online company conducted a test of the hypotheses, null hypothesis, P1 minus P2 equals 0. Alternative, P1 minus P2 does not equal 0, two-sided, where P1 is the proportion of customers similar to those in the study given advertisement 1 that would click and make a purchase, and P2 is the proportion of customers similar to those in the study given advertisement 2 that would click and make a purchase. The conditions for inference have been met. Okay, so we don't have to worry about checking any conditions here. They've already given us that the conditions are met. So part D says, one of the conditions for inference that was met was that n times p combined and n times 1 minus p combined are greater than or equal to 10 for each group, where p hat combined is the combined or pooled proportion. Explain why it is necessary to satisfy this condition. Notice that we are not asked here to check this condition. We are asked why it is important that we check this condition. So often this is called the large counts condition. And the reason we check the large counts condition is to make sure that our sampling distribution is approximately normal. So let's go ahead and start our answer here by saying, so, whoops, let's do this in blue. So we can assume the sampling distribution, and I'm going to be very specific here. The sampling distribution in this case is the sampling distribution of P1 hat minus P2 hat, which is the difference in sample proportions. And we're going to say that it is approximately normal. And I'm going to go a little bit further here. The reason why we want it to be approximately normal is because if we're going to do some inference and maybe do a significance test and calculate a p-value, we're going to use that normal distribution in order to find our p-value by first calculating a z-test statistic, which has to come from an approximately normal distribution. So I'm going to say here, and we can use a z-test statistic to calculate a p-value. Now, which parts of this do I think are crucial or critical in order to get full credit? Well, we of course need to say something about approximately normal. But here's the thing you need to be careful of. You have to be specific in your language about what we are saying is approximately normal. You can't just say it is approximately normal. You can't just say the distribution is approximately normal. Specifically, we want to say that the sampling distribution is approximately normal. So I think that those are the two parts that would be necessary for full credit. All right, now let's move on to part E here. It says the test resulted in a p-value of 0.2795. Interpret what this p-value measures in the context of the study. So listen, students, this right here is the holy grail of AP statistics. It is the interpretation of the p-value. And so to help us out here, instead of jumping right into the interpretation, I'm going to draw a picture of that sampling distribution, which will then help us to write the interpretation for the p-value. So here's the picture. Let's suppose we had our sampling distribution, which we just decided was approximately normal. And just to make this very clear here, I'm going to label this as the sampling distribution of p1 hat minus p2 hat. Now, when you calculate the p-value, remember, we always assume that the null hypothesis is true. And if the null hypothesis is true, then p1 minus p2 is equal to 0 would be the mean of the sampling distribution. Now, the statistic here based on the sample, well, let's do a little bit of a calculation here, all right? The p1 hat would be the sample proportion for advertisement 1 that ended up making a purchase. Well, we actually figured that out already. There were 22 people out of 100 that made a purchase using advertisement 1. That's 0.22. And we've already calculated the proportion of the customers that got advertisement 2 that made a purchase was 16 out of 100. And so now we can find p1 hat minus p2 hat. The difference in the sample proportions here would be 0.22 minus 0.16. We have a difference of proportions there of 0.06. That is going to show up in our picture here. This would be the difference in the sample proportions. And a p-value says, how likely is it to get that value or farther from what's expected purely by chance? So we want to know how likely is it that we would get a difference of sample proportions of 0.06 or greater. But let's be careful here. If you look back at the alternative hypothesis, you will notice it is two-sided, which means we need the equivalent area on the other side, which would be a difference of sample proportions of negative 0.06 or lower. So the p-value is just this shaded red region here, right? These two shaded red regions represent the p-value. And what we need to do now is we need to turn that into words, okay? So here is my interpretation of the p-value. Let's start with our assumption up front, which is the null hypothesis. So I'm going to say, assuming the proportion that make purchases for each treatment group is the same. And that's really just the null hypothesis. In fact, I'm going to write the null hypothesis in parentheses here. P1 minus P2 is equal to 0. There is a, and this is where we're going to give our p-value, which is a probability. Our p-value is 0.2795 probability of getting, now let's look at our picture here. We're trying to explain these values here of getting difference of sample proportions of 0.06 or greater. That gives me the right-hand side shaded region. That's this. Or negative 0.06 or lower is going to give me the other side of that normal distribution purely by chance. So there is our interpretation of the p-value. And let me try and highlight the parts that I think are important. Definitely, the p-value is a conditional probability, and the condition is the null hypothesis. So we need to say somewhere that we're assuming the null hypothesis is true. You definitely need to have the p-value in that whole interpretation and describing it as a probability or a conditional probability. And the other thing to check for is you've got your 0.06, which is the value that we got in our experiment, but you need this or greater. Similarly, negative 0.06, and you need that or lower. Okay, so let's move on to the next part. It says, based on the p-value, what conclusion should the online company make? Now, I'm hoping this one feels very comfortable to you. Essentially, what we're looking for here is a conclusion to the significance test, where we look at the p-value and we have to make some decision about the null hypothesis. And there's a pretty good formula for what this should look like. So we're going to start with because, and we're going to compare the p-value to the significance level. Okay, so because the p-value of 0.2795, which is a pretty big p-value, right, is greater than significance level. And let's just maybe go with our standard 0.05 here. Because our p-value is large, that means that this result, this difference of sample proportions of 0.06, very well could have happened purely by chance, even though it looks like advertisement 1 is better. So we're going to say that the company should fail to reject H null. Now, the next sentence here, we need to say whether or not we have convincing evidence for the alternative in the context of the problem. So we're going to say they do not have convincing evidence that of the alternative. Now, the alternative right here says that there is, in fact, a difference between the two proportions. So I'm going to say that there is a difference in the proportion of customers like these who would make purchases between the two advertisements. So let's take a look at the parts of the conclusion here that I think are most important here. You definitely have to compare your p-value to the alpha level. We call that linkage, and we need a greater than or a less than there. You have to make some decision about the null hypothesis. Either you reject the null or you fail to reject the null. And then you want to say whether you do or do not have convincing evidence for, and then what you have here is the alternative hypothesis, but you've put it in the context of the problem. So that wraps up question number 1. I hope you did okay on question number 1. That was the 25-minute question. And I think we are now ready to take a look at question number 2, which was the shorter of the two. This is the 15-minute question. So let's go ahead and jump into a new context here. So totally new problem. Let's go ahead and take a look at the setup on this one. All right, so here's what it says. A park ranger at a large national park wants to estimate the mean diameter of all the aspen trees in the park. The park ranger believes that due to environmental changes, the aspen trees are not growing as large as they were in 1975. Part A. Data collected in 1975 indicate that the distribution of diameter for aspen trees in this park was approximately normal, with a mean of 8 inches and a standard deviation of 2.5 inches. Find the approximate probability that a randomly selected aspen tree in this park in 1975 would have a diameter less than 5.5 inches. Okay, well, we're given here that the distribution is approximately normal, and we're also given the mean, and we're also given the standard deviation. So I'm going to start out with a picture on this one, where I'm going to draw the distribution and make a couple of labels here. We know that it's approximately normal. We know that the mean is 8, and we know that the standard deviation is 2.5. And so I could label in my picture here the mean of 8. And what we're trying to find out is the probability that the diameter would be less than 5.5 inches. Well, 5.5 inches, of course, is going to be below the mean of 8 inches. And I know I'm going to shade to the left here because I'm asked for less than 5.5 inches. Now, there's a couple of different ways that we could approach this, but I'm going to start by using the z-score calculation in Table A. So let's figure out what the z-score would be for that diameter of 5.5 inches. So we take whatever the value is, we first figure out how far it is away from the mean, and then we divide by the standard deviation. And the numbers work out really nice on this one. It's negative 2.5 divided by 2.5, which is going to give me a z-score of -1, which is telling me that that diameter of 5.5 is exactly 1 standard deviation below the mean. Now we could jump to Table A to help us out. So I'm going to go to my formula sheet here, and I've got Table A pulled up, and we're looking for a z-score of -1. So I'm going to go down here to -1.0, and then we want -1.00 because it's exactly 1 standard deviation below the mean. And I'm getting an area of about 0.1587. So from Table A, I'm going from Table A here in order to get my probability. I'm getting 0.1587 as a final answer. Now, that is not the only way to do this question. I could imagine some students who might have used the empirical rule here, also known as the 68, 95, 99.7 rule. So the other way we could approach this is, say, using the empirical rule. We know that 68% of the data should be within 1 standard deviation of the mean. Now, if 68% of the data is here, then we have 32% on the outside, which means 16 and 16. So to show the work on this one, I would say 100 minus 68 gives me the 32% on the 2 edges. But that 32, if we cut it in half, is going to give me 16%, which should be to the left of 5.5. So I'm giving 2 different answers. Now notice it's very, very close to what we got using Table A. So my guess is that either one of these approaches would be acceptable here. If you're using the z-score approach, you definitely want to show your calculation and then, of course, your answer from Table A. If you're using the empirical rule, you're going to want to show some sort of thinking and reasoning or explanation as to what you're doing in addition to your final answer. Now, I do know that it has been stated that for the 2020 exam, there will be no graphs that students will have to produce that would be required. So this picture that I have here of the normal distribution is just sort of extra and not necessary. Okay, moving to the next part. It says the park ranger selects a random sample of 30 aspen trees from the park in 2020 and measures their diameters. A dot plot of the diameters is shown below. Okay, part B, describe the distribution of aspen tree diameters from the sample. Very, very classic question here, describing a distribution for one variable where it's a quantitative variable. Very specific things that we know need to be included in the response for this. One of the ways that you can remember it is using the acronym SOX, which stands for shape, outlier, center, and spread. So we want to make sure that we address all of those within the context of the problem. So I'm going to start with the shape. And let's say the shape of the distribution And right here, I'm going to be very specific about what type of distribution. This is where I'm going to get my context of the problem in right off the bat. So what is the distribution? It's the distribution of Aspen tree diameters. So now that I've established context there, I don't have to continue to say over and over and over again, distribution of Aspen tree diameters. I can just say distribution, and clearly I've already identified what that distribution is at the very start of my solution here. Now, thinking about the shape on this one, sort of a weird shape here. I definitely wouldn't say that it's symmetric. In fact, it looks like it's being drawn out to the right a little bit there. So I would say that this is a skewed right distribution. But there's another important feature here that I want to make sure that we point out in terms of the shape of this distribution. And that's this big hole that we see between 7 and 8, often called a gap in the data. I want to make sure that we reference that as part of the shape here. So I'm going to say with a gap between 7 and 8 inches. So we've definitely taken care of shape there. Now, outliers, it doesn't appear to be any outliers there. There's no values that are extremely high or extremely low. Let's try and take care of these outliers and center in the same sentence here. And so when I think about the center on this one, because it's a skewed distribution, I would lean more towards using the median rather than the mean. And we have 30 trees here. So if I'm trying to find my median, I know it's going to be between the 15th and the 16th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15 and 16 are both right here. So I know that my median is going to be there at about 5.8-ish. So I'm going to say the center of the distribution is around, what do we say, 5.8 inches? And then I'm going to say with no obvious outliers. Okay, so that takes care of outliers and center. Now all we have to do is handle the spread. And we can measure that a number of different ways. The simplest of which is looking at the range, the highest value minus the lowest value. So let's go there on this one. Let's say the range of the distribution is, and I'm going to show my calculation here. I'm going to take the highest value, which looks to me to be about 10.2, and my lowest value looks like it's about 3.8. That's going to give me a range of about 6.4 inches. And that takes care of my spread. So in terms of what has to be included, we've sort of talked about this already, but you got to talk about the shape, you got to talk about the center, you got to talk about outliers, and you got to talk about some sort of measure of spread. And the other thing that's important here is the context of the problem, which we got right here with the Aspen tree diameters. Okay, let's move on to part C. It says, assume the conditions for inference have been met. The park ranger uses the sample data to construct a 95% confidence interval for the mean diameter of all aspens in the park in 2020 as 5.6 to 7.0 inches. Calculate the point estimate and the margin of error. Okay, so they've already done the work of finding the confidence interval. We want to know what the estimate was and then the margin of error that was added and subtracted. And there's a pretty straightforward calculation here. In order to get the point estimate, it's going to be the middle value between the two endpoints. So you can really just find the average by adding them together and dividing by 2. And that's going to give you 6.3 inches as the point estimate, or the guess for the mean diameter. And then we need the margin of error. And there's a couple of different ways that you could calculate this. One of which is to figure out the highest minus the lowest. But that would actually be 2 margin of errors, because you got your point estimate plus margin of error minus margin of error. You got 2 margins of error there. So you'd have to divide that by 2. And that would give you 0.7 inches. And so we know that this is really 6.3 inches plus or minus 0.7 inches. So that gives us our point estimate as well as the margin of error. Now, what has to be included? You're going to want to show a little bit of work along with your answer. for each one of those calculations. All right, part D. Based on the confidence interval, does the park ranger have convincing evidence that the mean diameter for all aspen trees in the park is different than 8 inches as it was in 1975? Well, if I look back at this confidence interval here, that gives me a list of the plausible values for the true mean diameter of all the aspen trees. So we think anywhere between 5.6 and 7.0 is believable. We do not think 8 is believable. So we do have convincing evidence that it's different than 8. So let's put that into words. First, make sure we answer the question. Yes, we do have convincing evidence. And then we need our reasoning. All of the plausible values for the mean diameter are greater than 8 inches. Another way of saying that is that 8 is not contained within the interval. So the park ranger has convincing evidence and we're going to say here at what alpha level. Because this is a 95% confidence interval, our alpha level here would be the complement of that at 0.05. So we has convincing evidence at alpha equals 0.05 that the 2020 mean diameter does not equal 8. So what should be included here for full credit? Of course, you got to answer the question that's being asked. I like this idea of thinking of the values in a confidence interval as the plausible values. And then you want to somehow say that 8's not contained within the interval. So you either could just say it right out front or say that all of the plausible values are greater than 8. I'm sorry, not greater than 8. This would be less than 8. We got to switch this up here. My apologies. Oops. Are less than 8. Either one of those would count for explaining the reasoning as to why. And then I do also think that it's important that you clearly state what your significance level is as it relates to the confidence level. Okay, final question here. Number 8 says aspen trees tend to be smaller in the highlands of the park because they're subject to strong winds. While the number of aspen trees in the highlands of the park is about the same as the number of aspen trees in the lowlands of the park ranger is concerned that 24 out of the 30 trees in the sample came from the highlands. Propose a sampling method to address this concern and describe the benefit of using that sampling method. Okay, 24 out of the 30, when half of the trees are in the highlands and half of the trees are in the lowlands, if you take a random sample, you would hope that you'd get about half and half. And here, very clearly, we got a lot more from the highlands, which maybe explains why we have so many values that are a little bit lower here in our distribution. So how can we be sure that we get the same amount of trees from the highlands as the lowlands? Well, a new sampling method, a better sampling method here would be to use a stratified random sample. And just to explain what we would do with a stratified random sample, we would take an SRS of 15 trees, exactly half, 15 trees from the highlands, and separate SRS of 15 trees in the highlands. I'm sorry, the lowlands. That's going to guarantee 15 from the highlands and 15 from the lowlands. So what is the advantage to that? Well, instead of this situation like we have here, where maybe our guess for the true mean is a little bit lower than the truth because we had so many trees from the highlands, if we get a good balance of highlands and lowlands, our estimate should be closer to the true value. We should have lower variability in the estimates here. So I'm going to give the second part of the answer here as to why this is better. This will reduce the variability of the estimates of the mean. Now, another way of saying that, if we're reducing the variability of the estimates, we are also increasing the precision. Precision is about variability there. Now, why is this important? It should make it easier for us to tell whether or not the true mean diameter is different than it was in 1975. Now, what should be included in this answer here? Of course, you have to give your better sampling method here, which would be a stratified random sample. And then you have to give a good explanation. And I like the explanation of reducing the variability, or equivalently, you could say increasing precision here. So that takes us to the end of the practice exam here. I would like to do one more thing here that I think might be valuable for everyone, and that's to look holistically at these two questions and all of the different parts and try to identify specifically where did each part come from in the curriculum. So I'm going to think about it in terms of the CED and the 7 units that we're responsible for on the AP exam this year. And I'm going to go back to question 1. And I just want to think about where each part comes from in the College Board CED. So part A, observational study or experiment. This comes from unit 3 in the CED, which talks about collecting data. And that's where you have all the stuff about sampling methods as well as experimental design. Part B, this question very clearly comes from unit 2 in the CED, which is 2 variable data. I know a lot of people think about 2 variable data as always being quantitative variables, but what we have here are 2 categorical variables that we're comparing. So this is 2 variable data, comes from unit 2. Part C, very clearly this one sticks out as a probability question, and that is unit 4 in the CED, which deals with probability and random variables and binomial and geometric random variables. Now moving on to the next part here, part D, asking about this condition here. This comes from unit 5, which is about sampling distributions. The next question, the holy grail of AP statistics, interpreting the p-value, is definitely a unit 6 question, which is inference, but specifically, this is inference for proportions. And then if you move down to part F, this is also in the same world of inference for proportions. So once again, this one is also unit 6, inference for proportions. Okay, let's move to question 2 and see if we can identify where each part comes from. Okay, part A, a normal distribution calculation. Sort of a classic normal distribution calculation, comes from unit 1. The end of unit 1 talks about normal distribution calculations. And that's where you have all of the 1 variable data. Now, also a very classic question, part B, describing a distribution. Probably the most classic type question we could ask from unit 1, which is about 1 variable data, asking us to describe a distribution. Part C is asking about margin of error for a confidence interval. So we are now talking about inference, but this is unit 7 because it's inference for means instead of inference for proportions. Similarly here, part D is also asking about a confidence interval, which is inference. And we're still in the world of means here. So this is also unit 7, inference for means. And then the last question here sort of jumps us backwards into sampling techniques, which we know we've already talked about. This was unit 3, which talked about collecting data. So listen, if you look holistically at these 2 questions and all of the different parts, you are going to see that it covers the entirety of units 1 through 7 in the CED, which is something that I think you can expect on the actual AP exam. Now, a couple other last minute hints that I'm going to give you here are things, my predictions, and I have no clue, no idea about anything on the AP exam, but here are just some of my predictions about it. First of all, I do think that one question will be about proportions and one question will be about means. And for us, question number 1 was the one that dealt with proportions, and question number 2 was the question that dealt with means. Secondly, I think that somewhere on the AP exam, you're going to see a confidence interval, and somewhere you're going to see a significance test, big parts of AP statistics. So we actually saw the significance test in question number 1, and we saw the confidence interval in question number 2. Next prediction here is that I do think that one of the questions will be a 1 sample scenario, and one of the questions will be a 2 sample or 2 groups scenario. So question number 1, we had the 2 groups there because of the experiment. In question number 2, we just had 1 sample of 30 aspen trees. And then my final last little tip is, and this is just a personal preference of mine, but I think that somewhere they're going to ask you about conditions, and rather than checking the conditions, they're going to ask you why we check those conditions. So that showed up for us in the question where we had to talk about n times p combined and n times 1 minus p combined, and explain why we check that condition. So hopefully that gives you some things to think about. I hope that you did well on this practice exam. You are going to get another opportunity to do a practice exam tomorrow with Mr. Murphy. Same conditions. It's going to be timed just like we did yesterday. And then Mr. Murphy is going to take you through the solutions on that practice exam on Thursday. And then both of us are going to be teaching on Friday, where we'll give you some AP exam tips and then wish you well as you move into your exams. So if this was helpful for you, please give me a thumbs up there on YouTube, and hope to see you soon.